Hey YouTube, Tim Unkert here. This is my Algebra 2 finals review. If you're finding this from across the web, maybe you want to use it on your own in your own classes, that's fine. And if you're a student watching this, just take notes because you can use those notes. So let's get started. So let's look at problem 1 here. We have 25% of 520. So one way we can do this is we can do 0.25 and then multiply that, so I'm going to use this mid dot here to indicate multiplication, by 520. Okay, and if we do that, let me get my calculator here. So 0.25 times 520 is 130. Okay, problem 2, we are multiplying the binomial x squared plus 7 by the trinomial 3x squared minus 3x minus 9. So first off, I'm going to multiply all the x squared. So we'll do x squared times 3x squared, which is 3x to the 4th power. Then we're going to do x squared times a negative 3x. That's going to be a minus 3x cubed. Remember, even though there's not a 1 here, this is x to the 1st power. So when we have a base of x to the 2nd power times x to the 1st power, you add the exponents to get 3. In this case, we added the exponents to get 4. Okay, then I'm going to do x squared times negative 9. It's going to be minus 9x squared. Okay, now we're going to multiply the 7 by the 3x. So that's going to give us a plus 21x squared. And then the 7 by minus 3x there, that's going to be minus 21x. And finally the 7 by the minus 9, which is minus 63. Okay, so we want to combine like terms if we can. We don't have anything like 3x to the 4th, so I'm just going to write it down here. And when I go ahead and write something down below, after I combine it, I'll just cross it off to keep track. Next we have minus 3x cubed. We don't have anything like that, so I'm just going to write minus 3x cubed. And we'll cross that off. We can combine a minus 9x squared with a 21 x squared to get 12x squared. So we'll do plus 12x squared. And we'll cross these two off. And then we have minus 21x. Let's see if I can move this over a little bit. Yeah, there we go. All right, so minus 21x. And then minus 63. And now that we've crossed everything off, we know that this is our solution here. Okay, let's go to problem 3. Problem 3, if q minus 9 equals 19, what is the value of q? Well, we have to solve for q, so we're going to add 9 to both sides. Okay. 9 minus 9 is 0. So we're going to get q is equal to 28 here because we have 19 plus 9. So q equals 28 for that one. All right, next one, the function f is defined by f of x equals 2x minus 5. What is the value of f of x when x equals 6? So we're finding f of 6. So f of 6 is going to equal 2 times 6. Everywhere there's an x, we'll put a 6 minus 5. 2 times 6 is 12. And 12 minus 5 is 7, so my solution here is 7. All right, keep going. Now we have some polynomial division. All right, so we have x cubed plus x squared minus 14x minus 24. So x cubed plus x squared minus 14x minus 24. And we're dividing by x plus 2. So we've got to think, what do we have to multiply x by to get x cubed? Well, if we multiply x by x squared, we'll get x cubed. Okay, and then we also have to multiply x squared by 2, so we have plus 2x squared. And we're subtracting that from all of this. So x cubed minus x cubed is 0. X squared minus 2x squared is minus x squared. And then we're bringing down minus 14x and then minus 24. So what do we have to multiply now by x to get negative x squared? Well, that's going to be a minus x. So negative x times x is negative x squared. Negative x times 2 is minus 2x. So we're subtracting this. Negative x squared minus negative x squared is 0. Negative 14x squared minus 2x squared is negative 12x squared. Bring down the minus 24 here. Okay, now what do we have to multiply x by to get negative 12x? Well, minus 12. There we go. So negative 12 times x is negative 12x. And negative 12 times 2 is minus 24. We subtract this off, and we get 0 here as a remainder. So x squared minus x minus 12 is our solution. And there we go with that one. All right, let's try problem 6. We got x cubed minus x squared minus 25x plus 25, and we're dividing by x minus 1. So we've got to think, what do I multiply x by to get x cubed? Well, as in the previous problem, if we multiply it by x squared, we get x cubed. So x squared times x is x cubed. X squared times negative 1 is minus x squared. So we subtract this off, and these subtract off, and now we just bring down this, because this minus this is 0, and then we bring down our minus 25x. Plus 25. So then, what do I have to multiply x by to get negative 25x? Well, minus 25. Negative 25 times x is negative 25x. And negative 25 times negative 1 is positive 25. And when we subtract that, we get a remainder of 0. So this here, x squared minus 25, is our solution to this particular problem. So let's start with problem 7. It says find the zeros of the polynomial function f of x equals x cubed plus 11x squared plus 31x plus 21 when one of the given factors is x plus 3. So what we're going to do is we are going to, actually let me put that, we're going to do some polynomial division here. All right, so we're going to take x cubed plus 11x squared fix that plus 31x plus 21, and we're going to divide it by x plus 3. And then we're going to factor the solution. Okay, so first off, we do know one of the given factors is x plus 3, so if we set that factor equal to 0, we can find one of the zeros to start. So if we set this equal to 0, we'd subtract 3 from both sides here. These 3's would cancel, and we get x equals negative 3 is one of our zeros. So we've got that. We're going to divide this cubic by this binomial here, get a trinomial and factor that, and then find the two other factors. Okay, so we want to see how many times x plus 3 goes into this. So first we have to think, what do I have to multiply x by to get x cubed? Well, x squared. All right, so x squared times x is x cubed. X squared times 3 is 3x squared. We're going to subtract this part off. And 11 minus 3 is 8x squared plus 31x plus 21. Okay, we have to think of what we need to multiply x by to get 8x squared, so we're going to do plus 8. So 8 times x, plus 8x. 8x times x is 8x squared. And 8x times 3 is 24x. I'm going to keep going and subtract this. 8x squared minus 8x squared is 0. 31x minus 24x is 7x. And then we've got the plus 21. So then we got to think, what do we multiply x by to get 7x? Well, it's going to be plus 7. So we get 7x, and then 7 times 3 is 21. So our remainder is going to be 0 here, which is what we want. Now we've got to factor x squared plus 8x plus 7. So list of factors of 7, those are 1 and 7. Since I have plus and plus, I know I'm going to use positive factors. 1 times 7 is 7, and 1 plus 7 is 8, so those are the factors. So we say this is x plus 1 times x plus 7. And so if we set each of these factors equal to 0, so x plus 1 equals 0, we'll subtract 1 from both sides. And we get x equals negative 1 as one of the factors. And also set x plus 7 equal to 0. Subtract 7. We get x equals negative 7. So our three zeros are x equals negative 3, x equals negative 1, and x equals negative 7. All right, let's go on to problem 8. All right, problem 8. We have a polynomial f of x equals x cubed plus 11x squared plus 34x plus 24, when one of the factors is x plus 1. So we can find one of the zeros by setting this factor equal to 0. And to solve for x, we'd have to subtract 1. And we get x equals negative 1 as one of the zeros. We can also do some polynomial division. We've got x cubed plus 11x squared plus 34x plus 24. We'll divide by x plus 1. So to get x to equal x cubed, we'd have to multiply by x squared. X squared times x is x cubed. X squared times 1 is x squared, or 1x squared. If we subtract here, x cubed minus x cubed is 0. 11x squared minus 1x squared is 10x squared. Bring down the 34x, so plus 34x. And plus 24. Okay, to get x to be 10x squared, we'd have to multiply by 10x, so plus 10x. Ten x times x is 10x squared. 10x times 1 is 10x. Okay, so 34x minus 10x is 24x. Plus 24. So to get x to be 24x, we'd have to multiply by 24. So we get 24x. 24 times 1 is 24. We subtract that, we get a remainder of 0, which we should get. And now we got a factor x squared plus 10x plus 24. I'm going to just go down here, and we'll just do problems 7 and 8, and I'll stop the video there and then erase all the stuff and do 9 and 10. Okay, so we got x squared plus 10x plus 24. The factors of 24, we got a positive and a positive here, so could do like 1 and 24 are factors of 24, but those don't add to 10. 2 and 12, those still don't add to 10. 3 and 8, that adds to 11, getting a little bit closer. 4 and 6, though, those add to 10. So the factored form here is x plus 6, or x plus 4, times x plus 6. All right, now if we set either of these to 0, because when this equals, f of x equals 0, so if this equals 0, we define the zeros. So I'm going to set x plus 4 equal to 0. I'm going to subtract 4 from both sides. 4 minus 4 is 0. We got x equals negative 4. So that's a 0. And then x plus 6 equals 0. Subtract 6 from both sides. We get x equals negative 6 is another 0. So our zeros are x equals negative 6, x equals negative 4, and remember x equals negative 1 here.
Hi guys, I'm hoping you're finding this video useful to this point. If you are, you know what you could do that would help me out a lot is give the video a like and subscribe. It really helps with the algorithm and it means a ton to me. All right, let's get back to the video. So let's multiply 5x to the fifth y squared times x cubed y, the quantity x cubed y minus 7 times x y squared. So we're going to distribute. So we're going to have 5 x to the fifth times x cubed, you add the exponent, so it'll be x to the eighth. And then y squared times y, this is really like a y to the first, so it's 2 plus 1. It's going to be y cubed. And then minus 5 times 7 is 35. X to the fifth times x, remember this is like an x to the first, so that's going to be x to the sixth. And then we have y squared times y squared, 2 plus 2, so y to the fourth. And these two terms are not like terms, so we just have to leave it like this. That's as far as we can go there. Okay, the next one, we have circle A has a radius of 5n, and circle B has a radius of 10n. How many times circle A's area is circle B's area? Okay, so in terms of the ratios, circle B has twice the length of circle A, but remember the area for a circle is pi times the radius squared. So, we're going to go double the radius, but when we square that, we're going 2 times 2. So it's actually going to be 4 times circle A's area. Okay, so it's 4 times as large. All right. Let's go down to problem 13 here. We have this equation x squared over 81 equals 25. What are the solutions to the given equation? Okay, so x squared over 81 equals 25. There's a couple of ways you can approach this problem. I'm going to multiply both sides by 81. The 81s will cancel out. We'll get x squared. I'm going to leave it as 25 times 81. We're going to take the square root of both sides to solve for x. And this time we're not going to just do the principal square root, so not just the positive, because we're squaring x, it could be either positive or negative. So it's going to be positive or negative, and it's going to be 5 times 9. So that's going to be positive or negative 45. So the two solutions, it could either be x equals 45 or x equals negative 45 could also work. Okay, let's do the next one. Solve for x. We have 3 to the x plus 1 power equals 243. 243 is 3 to the 5th power. And you can figure that out if you want to figure that out in decimals. Just start multiplying 3's together. You're going to multiply 5 3's together to get 243. So we're going to set x plus 1 equal to 5. To solve for x, we've got to get rid of the addition of 1, so we're going to subtract 1. 1 minus 1 is 0, so we cross those out. We get x equals 5 minus 1, so x equals 4. All right, last one we're going to cover in this video is problem 15. So we have 5 to the x power equals 625. So if you put this in decimals and you just start multiplying 5's together, you're going to notice that it's 5 to the fourth power is 625. So x is going to equal 4. We have log base 3 of 81 equals x, and we want to solve for x. So we can write this in exponential form as 3. We use the base here, 3 to the x power. That's going to equal 81. So we want to say what power of 3 equals 81? Well, if we do 3 times 3, that's going to give me 9. And then we multiply by 3 again. That gives me 27. And we multiply by 3 again, we get 81. So that's 1, 2, 3, 4, 3. So 3 to the fourth power equals 81. So x is 4. Okay, let's keep going. Problem 17, we have a log base 125 of 625 equals x. Solve for x. So we want to use change of base, so we can set this up as log base c of 625 over log base c of 125. And that is going to be equal to x. Now we want to pick a c here that we can multiply by itself enough times to get both 625 and 125. The number that works is 5. So we could change this to log base 5 of 625 over log base 5 of 125. Okay, so let's go down here. So how many 5s do we have to multiply together to get 625? Well, if we do 5 times 5, that's 25. We multiply by 5 again, that is 125. And if we multiply by 5 again, that's 625. So 4 5s. So it's going to be 5 to the fourth power. So we put 4 on top. And then how many 5s do we have to multiply to get 125? Well, 5 times 5 is 25. Times 5 again, that's 125. So that's 3 5s. So our solution here is going to be x equals 4/3. Okay, let's do the next one. Log base x of 27 equals 3. Solve for x. So we can write this in exponential form. We use our base x to the third power equals 27. Well, what number could I take and take 3 of that number, multiply it together and get 27? Well, if we do 1 times 1 times 1, that's just going to be plain old 1. Make this a little bit thicker for you. Okay, so if we do 2 times 2 times 2, that's going to be 8. So that's still not there. But if we do 3 times 3 times 3, 3 times 3 is 9, times 3 again is 27. So x, that's a bad 7 there. X should be 3. All right, let's keep going. Okay, problem 19. Log base 7 of 1 over 2,401 equals x. Solve for x. So first off, I'm going to think about how many 7s do I have to multiply together to get 2,041. So if I do 7 times 7, that's 49. Times 7 again, that's going to be 343. Okay, and let's do 343 times 7. So we get 7 times 3 is 1. 7 times 4 is 28, plus 2 is 0. 30, so we put the 0 down there. And then 7 times 3 is 21, plus 3 is 24. So it's actually another 7. 4 7s gives us 2,041. Now this is 1 over 2,000, sorry, 2,401. This is 1 over 2,401. So in this case, basically we're saying 7 to what power equals 1 over 2,401. Now to bring it to the denominator, we have to have a negative exponent. So it would have to be to the negative 4 power would equal 1 over 2,401. So x is going to equal negative 4. Okay, next one, log base 81 of 27 equals x, solve for x. Okay, so we're going to use change of base rule. We'll say x equals log base c of 27 over log base c of 81. Okay, so what's our c going to be? Well, I think our c should be 3, so we'll do log base 3 of 27 over log base 3 of 81. So log base 3 of 27, that's going to be 3, because 3 to the third power is 27. If I take 3 times 3 times 3, that's 3 to the third power, that equals 27. Okay, and then how many 3's do I have to multiply to get 81? Well, I do 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So it's going to be 4 3's. So in this case, x is going to equal 3/4. All right, next one. Can you use natural log for the change of base rule? Yes. All right. Next one. What is the next term in the arithmetic series? Okay, so we go from -2 to 4. So this problem is bunk because I just had a jump of +6, so I should go from 4 to 10. But I made it 4. So this should be, let's make this 0 here. Okay, let's fix it. So if I go from 0 to 4 to 8 to 12, um, then my next term would be 16. Okay, but that problem is meh. Let's do meh. All right, next one, problem 23. Find the missing term in the arithmetic sequence by finding the arithmetic mean. Okay, so we're going to add these two numbers and divide by 2. And if I can draw a -8 better. So -8 plus 16 divided by 2. That's how we get the arithmetic mean. We average the two numbers, so mean, average, right? So -8 plus 16 is 8. Divide that by 2, and we get a 4. So our next term should be 4, which makes sense. Go from -8 to 4, you jump by 12, and then 4 plus 12 is 16. What is the sum of all odd numbers from 0 to 350? So the sum formula is going to be the sum of n numbers equals the number of terms. So sum of n terms equals the number of terms divided by 2 times the first term, which we can indicate with a sub 1, plus the last term, which we can indicate with a sub n. Okay, so we can figure out a sub 1 and a sub n pretty easily. Let's start with those. So a sub 1 is going to be the first odd number from 0 to 350. That's going to be 1. A sub n is going to be the last odd number from 0 to 350, which is going to be 349. Okay, but we need to find the number of terms. So one way we can do that is with the explicit definition. So I could say a sub n equals a sub 1 plus n minus 1 times the common difference d. All right, so the common difference d is going to be 2 because there's a difference of 2 between each odd number, so 1, 3, 5, etc. Um, we know a sub n, so 349. That's going to equal 1 plus, we don't know what n is, so we have n minus 1 times our common difference of 2. So we can distribute the 2, we can multiply it by the n, and we can multiply it by the minus 1 here, and we can start to work this out and solve for n. So we get 349 equals 1 plus, we're going to have 2 times n is 2n, minus 2 times 1, which is 2. And we can continue to neaten up the right-hand side here by combining like terms. The 1 plus minus 2 is going to be a minus 1. We fix that n there. So we have 2n minus 1, and that equals 349. And so what should we do to solve for n? We should add 1 to both sides. And we're going to get 350 equals 2n. Then if we divide by 2, well, n is going to be 175. All right, so we're looking for the sum here, the sum of 175 terms. That's going to equal 175 divided by 2 times 1 plus 349. And we can go to Desmos and figure out what this is. So now we're at Desmos, we'll do 175 divided by 2 times 1 plus 349, and that's 30,625. So our sum here of the 175 terms is 30,625. All right, let's keep going. Go down to problem 25. Write the sum of the following arithmetic series in sigma notation with a capital sigma. All right, so we got to figure out the number of terms here. So we can say, we can use our explicit definition to do that. A sub n equals a sub 1, this is the general one, plus n minus 1 times the common difference d. So this negative 9 is a sub 1. A sub n is 33. And the common difference d is 2 because there's a difference of 2 between each number. So we're going to say 33 equals negative 9 plus n minus 1 times 2. Okay, so we'll distribute again. So we'll get negative 9 plus 2n minus 2. That's equal to 33. If we combine like terms over here, we have 2n minus 11 equals 33. If we add 11 to both sides, so we get 44 equals 2n. So if we divide both sides by 2, we get n equals 22. All right. So our general form for summation notations, we have this uppercase sigma. I know everyone likes that. So we start at n equals 1. We go to whatever n is. And we have the first term a sub 1 plus n minus 1 times common difference d. So that's the form we're going to write. So we're going to create our sigma here, a nice big sigma. We'll say n equals 1. And we have 22 terms, so we go to 22, because we found that right here. And our first term is -9 plus, and we have n minus 1 times our common difference, which is 2. And there we go. That's our arithmetic series written in summation notation. Okay, I'm going to race a little bit and we'll move to problem 26. All right, in problem 26, we're finding the common ratio of the following geometric sequence. We can do that simply by dividing a term by the previous term. So the common ratio R, if we take the second term, for instance, and divide by the first term, 12 divided by 4, we get our common ratio of 3. We would have gotten that also if we divided 36 by 12. So our common ratio is 3 in this particular one. All right, let's go down to problem 27. Find the missing term in the following geometric sequence by finding the geometric mean or its opposite to show your work. Okay, so we are going to take the square root of the product of the two numbers surrounding this. So the geometric mean, which we can abbreviate as GM, that's going to be the square root of 1 times 9, which is just going to be the square root of, well, 1 times 9 is 9. So the geometric mean is going to be 3. So the missing term could be 3 or -3. It would be -3 if the common ratio was negative. Okay. All right. The next one. What is the sum of the following geometric series? So the sum of n terms is going to be the first term, a sub 1, times 1 minus common ratio to the nth power divided by 1 minus the common ratio. Okay, so what do we need to know? We need to know the common ratio, a sub 1, and we need to know the number of terms. So the first term, a sub 1, is going to be 3. That's easy. The common ratio, we can take the second term divided by the first, so 12 divided by 3, that's 4. So we need to know two of those things, but we need to know the explicit, we need to know the nth term, so we need to do the explicit definition, which is going to be a sub n equals a sub 1 times the common ratio r to the n minus 1 power. Okay, so we're going to say 12,288. That's going to equal the first term 3 times the common ratio of 4 to the n minus 1 power. And we'll divide both sides by 3. Okay, so let's divide 12,288 divided by 3, and we get 4,096. So we get 4,096 equals 4 to, because these 3's cancel, right? 4 to the n minus 1 power. So we can put 4 to the x minus 1 power equals 4,096, and that'll give us a straight line through what x is here. Okay, so I'm going to do that. So I'm going to say 4 raised to the x minus 1 power equals 4,096. I see that goes right through 7. So my mistake. 4 to the 6th power is 4096, but x is going to be 7, right? 7 minus 1 is 6. Okay. So n has to be 7. Hopefully that makes sense. All right, so now we've got this formula over here. So take stock of this, maybe write this down, pause the video right now, because I'm going to have to erase it, and then we'll go use these numbers here now that I know that n equals 7. Okay, so hopefully you've written that down. Let's erase this stuff. Okay, so we're going to say the sum of the 7 terms equals first term 3 times 1 minus 4 to the 7th power all over 1 minus 4. Let's go to Desmos for that. Okay, put that into Desmos, and we get 16,383. So the sum of the 7 terms here is 16,383. Just check that, make sure. Yep. Okay, so this is my solution here. All right, let's keep going. Let's look at problem 29. Evaluate from n equals 1 to 14 this expression 3 times 2 to the n minus 1 power. So this is the sum from n equals 1 to 14 of this expression. So we need to know the number of terms. Since we start at 1 and we go to 14, there's going to be 14 terms. We need to know the first term, which if we enter in 1 for n, so it's going to be 3 times 2 to the 1 minus 1 power, which is 3 times 2 to the 0 power, which any non-zero number to the 0 power is 1. So this is 3 times 1. So for my first term is 3. And we need to know the common ratio. So every time I increase n, I multiply by 2. So the common ratio here is 2. And now we can say that the sum of the 14 terms equals the first term, 3, times 1 minus common ratio 2 to the 14th power, the number of terms, over 1 minus the common ratio 2. All right, so we'll go to Desmos now, and let's delete all this stuff. Okay, and let's see, what am I doing here? 3, okay, so 3 times 1 minus 2 to the 14th power divided by 1 minus 2, and we get 49,149. And that's our solution for that one. All right, let's clear up this. All right, this next one, we're starting from n equals 0 to 12. So we have to count the 0. So that's actually going to give us not 12 terms, but 13 terms. Our first term is going to be 4 times negative 5. This time we'll start with n equals 0. So negative 5 to the n power, which is 0. So it's going to be 4 times 1, which is going to be 4. Our common ratio this time is going to be negative 5, because every time we raise the power of n, we multiply by negative 5. All right, so our sum of the 13 terms is going to equal our first term, 4, times 1 minus negative 5 to the 13th power divided by 1 minus negative 5. So our sum of our 13 terms is going to equal, well, we'll put this into decimal. So let's see, what was my first term here? 4. Okay. So 4 times 1 minus negative 5 to the 13th power divided by 1 minus negative 5. And we get, let me write that down, 813,802,084. So we have 813,802,084. And that's my solution for that one. All right, problem 31, convert 60 degrees to radians. So 60 degrees, and we're going to multiply by a conversion factor. So there are 180 degrees for every pi radians. I don't know why I wrote an equal sign there. Getting ahead of myself. So the degrees will cancel. Let's make that a little bit bigger. The degrees here will cancel. And we get 60 pi over 180 radians. So we can reduce this. 60 goes into 183 times, so I can cross this out right at 1, cross this out right at 3. 1 pi is just pi, so this becomes, our solution becomes pi over 3 radians. Okay, next one, convert 5/3 pi, that should be radians to degrees. So we're going to multiply by pi radians. I'm just going to write rad because I'm going to run out of room. Over 180 degrees, or not pi radians for 180 degrees rather. Sorry, I misspoke there. All right, so these are going to cancel. We'll multiply across. And we're going to get 5 times 180 degrees divided by 3. 3 goes into 180 60 times, so this is just going to be 5 times 60 divided by 1, which is just 5 times 60. So our solution here is 300 degrees, and make sure you have that degree symbol there. So 300 degrees. All right, last one. 4x minus 10 equals 30. What is the value of 18x? Let's add 10 to both sides. And we get 4x equals 40. Divide by 4. So we get x equals 10. Well, we're not done yet. We have to do 18 times 10, which is 180. All right, there we go. Wow, you got through almost a full hour of the finals review. You must really like this video. Hey, do you know someone that would also like this video? Could you do me a favor and share it with them? Thanks a lot. Hope to see you in the next one.